Hello! We finally got to Chapter P, Section 5, Factoring Polynomials. I will say, we do go through the factoring fairly quickly. Again, it's really just a refresher from Honors Algebra 2. And so again, I don't know what to say. We do go through this pretty quickly. Factoring is the process of writing polynomials as what? Well, as the product of two or more polynomials. As the product of two or more polynomials. Product meaning multiplication. Okay, it's the product of two or more polynomials. Okay, this word, product, means multiplication. So if you see addition and subtraction between your terms, it's got to be back-to-back multiplication to be in factored form. Polynomials that cannot be factored using integer coefficients are said to be prime. Excuse me, for example, 2x minus 3. That's prime. There is no GCF other than 1. Okay? In any factoring problem, the first step is to always look for that greatest common factor. You always try to look for a GCF. Lots of different ways to factor. We're going to learn something new this year. I don't think you've seen it in any previous math class. Maybe you have. If you've taken calculus, you might have seen that type of factoring, but that's coming up. I think this P5 I break down into 4 separate lessons, which still is fast going through factoring, if you ask me. The GCF, the greatest common factor, is an expression of the highest degree, so it's the biggest thing that you can take out. That divides each term of the polynomial. Excuse me. Folks, from now on, I want you to think of factoring as division. Okay? If you're in class and I say factor means, I want you to say divide, because factor does mean to divide. Factoring is reversing multiplication. When you're reversing multiplication, you are dividing. Okay? Factoring is reversing polynomial multiplication. You are dividing out common factors. All right. Some easy examples. Factor out the greatest common factor, the GCF. Well, what does each term have in common besides 1? Because remember, 1 is always there. Well, I'm looking, 12 and 8 have a common factor. 12 and 8 have a 4 in common. X to the power of 4, x to the power of 2. The highest degree that I can take out of each one is x squared. This one, I look at it this way and think of it this way. This guy's got 4 x's to give up, and this guy's only got 2 x's to give up. And so to keep it even, I can only take 2 x's out of each of them. So now, once I have my GCF, and the directions are to factor it out, I do have to include excuse me, the remaining part after I factor it out. Factor does mean divide. What you're really doing is taking 12 x to the power of 4, dividing it by 4 x to the power of 2. Okay, when you divide this, that becomes a 3. And when you divide this, that becomes an x squared. And that's what goes inside here. And maybe you don't think of factoring that way, but it's a lot easier to think of factoring that way when we get to the more trickier types of factoring problems. So 12 divided by 4 is 3. X to the power of 4 divided by x squared is x squared. Negative divided by positive is negative. 8 divided by 4 rather is 2. And that x squared is that x squared. It's just going to become a 1. And so that 2 times 1 is 2. Final answer. Not too terribly difficult. All right. What does each term have in common in this? Well, this one's a little tricky. And I'm going to tell you that there is a factoring packet. I know. You got done with the radicals packet, now you're going to have a factoring packet. You need to print that out, please. Factoring packet looks like this, okay? It's 4 pages. I'm going to have you scan it again, and I'll print them out and grade them. Notice here, it says, factor out the GCF from each polynomial. You can't just put the GCF here. You have to put the product of the two things with the GCF on the outside, just like I did here. Okay? Also, up here it says, for all of the problems, be sure to factor out leading negatives. That's a leading negative. You're going to take the negative out. Which means when you take a negative out, you've got to change the sign of everything in the group. Okay? Leading negatives come out. These problems in the factoring packet, they are GCF problems, just like this. Okay? This is actually the middle step of when you're factoring by grouping. But what does each one of these terms have in common? Now remember, terms are separated by addition and subtraction. This is all connected together by multiplication. There's my subtraction, and here's my other term. Okay? So what does this term and this term have in common? Well, if you said quantity x plus 5, you are correct. So that is my GCF. They each have an x plus 5 in common. So I take it out just one time. Factor means divide. I'm going to divide this term by this, and then I'm going to divide this term by this. Okay, so off on the side, and this is what I do in class. So I will do this in the video for you. You know, you should annotate your notes. In other words, everything that I say, I'm not going to write down, nor would I have written it down in a live lesson in the classroom. But this I'll write down, since, you know, if I was in class, I would do a side thing for explaining. All right, so 3 times x times quantity x plus 5. If I'm dividing this term by x plus 5, guess what? That's going to divide out, leaving me with 3x. So again, when I divide this term by x plus 5, I'm left with 3x in the grouping. The sign is subtract. When I divide 2 times this quantity by that quantity, I'm left with 2. And that's my final answer. None of these items have anything in common other than 1. And it is a product of terms, this with this. Okay, so if you have questions, post on the discussion. I'd also like to mention that, you know, instead of watching this video in class, you could pre-watch it the night before and then choose to work on the homework assignment in class and get questions answered. So that's one of your options for you too, versus trying to have a live Google Meet and in-class teaching. We'll see how it goes. Factor by grouping. Okay. Some polynomials have only a GCF of 1, but rearranging terms that have a common factor sometimes helps us. So we rearrange the lineup. You know, like 1 plus 2 plus 3 plus 4 could be thought of as 4 plus 3 plus 2 plus 1. I can rearrange them as long as I'm not changing any signs. Does each term have one thing in common besides 1? Like everything. Well, this only has a 1 and an x cubed, but this doesn't have an x cubed, so I can't take an x cubed out of all 4 of these terms. Remember, terms are separated by addition and subtraction. You know, 3 divides 12, but 3 won't divide 4. So, no, there's no GCF here other than 1. So we're going to say no. So there's no GCF. All right, then I got to do a different method. I have to group it. Now, usually, not always, but usually, if you group the first 2 and the second 2, you can get some common factors. Sometimes you do have to move them around. x to the power of 3, subtract x to the power of 2. I'm going to group those two. I always put plus in between. Folks, please always put plus in between and shove the negative in. I'm going to show you when there's a subtraction here how that benefits you to put the negative in and always put a plus sign here. Okay, so maybe annotate your notes. Always use plus between your groups. Now, this was a positive 4, so I'm just going to write 4x subtract 12. Okay, so I grouped 2 and 2. Sometimes you have to group 3 and 1. Be careful. So I grouped 2 and 2, and now I'm looking for a GCF in each group. Okay, so what's GCF here? X squared. I'm going to factor it out. Factor means divide. X to the third divided by x squared is x. Sign is subtract. 3x squared divided by x squared is 3. Over here, I'm going to take out a 4. That's the only thing these two terms have in common. It's positive, so I'm going to do plus 4 times the quantity. Well, 4x divided by 4 is x, and negative 12 divided by 4 is negative 3. I'm not done because I have two terms separated by an addition sign. Okay, this got to be back-to-back multiplication to be finished. What do these two terms have in common? Well, when I look at that, I see that's x squared times quantity x minus 3. And when I look at this, I see that's 4 times that same quantity x minus 3. That's what they have in common. Again, you're going to see that on this page 1 of the factoring packet. X minus 2, 2x minus 2. They have an x minus 2. Students either get this whole section right or the whole section wrong. So make sure that's not happening to you. I've got an x minus 3. Folks, I'm going to divide it out of each term. So it's only going to be there one time. It's like when I take a GCF out of something like this. You know, these two had a 4 and an x squared in common. I just write it one time. I know it's a little bit weirder to look at and to understand here. You're like, but it's coming out 2 times. No, I'm dividing this term by this, and then this term by this. So if I cover this up, I've got x squared times quantity x minus 3 divided by that is simply x squared. And then when I divide this term by this x minus 3, which is on the outside, I get a plus 4. And I'm done. Okay. Another one, factor by grouping. I look and I'm like third power, no power, can't take anything out. 2, I could take out of a 6 and a 12, but not out of a 1. So I have nothing that all 4 terms at the same time have in common, so I have to group and try to factor. The first 2 do have something in common, and so does this. So I'm going to group x cubed plus 6x squared. I told you before, always put a plus in between. Always put a plus in between. And shove that negative inside. That negative belongs to the 2. Alright, now I'm ready to take my GCF out of here. X squared. What's left? X plus 6. What do these have in common? Negative 2. This is a leading negative. I'm going to pull it out now. Negative. What do these have in common? 2. What's left? Negative 2x divided by negative 2 is x. Negative 12 divided by negative 2 is plus 6. I say shove the negative in and then factor it out so you remember to change the sign of this. Okay, so always write your 2 groups and always put plus in. If this is negative, shove it inside and then factor it out in the next step. We have an x plus 6 in common. If I take that out, what's left? An x squared minus 2. This comes out one time. I'm dividing this term and this term by x plus 6. What's left? X squared minus 2. Why don't you pause the video and try this one on your own? Okay, hopefully you paused the video and tried this one on your own. I am going to group x cubed minus x squared plus in the middle. Shove the negative 5 inside. Take an x squared out. So this is x subtract. Well, anything divided by itself is 1. I'm going to pull a negative 5 out. That's going to go away, leaving me with an x. And 5 divided by negative 5 is negative 1. Notice I'm not done. I've got this term and this term separated by subtraction. So I'm going to take it x minus 1 out. I'm factoring it out of both of those terms, and factor means divide. When I divide this product by this, I'm left with x squared. And when I divide this product by this, I'm left with negative 5. These are prime. You know, this 5 has no x, and this x squared has a prime number. Actually, it has a 1 in front of it, and this is a prime number. So I can't, there's no other common factors. I'm done. Okay, so hopefully factor by grouping is coming back to you, and hopefully in the past you have been taught to always put a plus inside here. All right, onward and upward. Factoring trinomials. So when we have a trinomial, trial and error is the best way to factor these trinomials. You know, polynomial with 3 terms. So trial and error is necessary for this type of factoring. These are the fun kind, especially when they're a little bit tricky and the numbers get larger. Consider the trinomial x squared plus 8x plus 15. This one's not that terrible to do. But your job is to factor it, and you will end up with 2 binomials. When you divide or factor, okay? 2 binomials. A trinomial is always going to factor into a product of 2 binomials. Here's the key. You have to talk to yourself. You have to ask yourself, what 2 numbers that when I multiply them, they give me the last term in that trinomial. And if I add or subtract those same 2 factors or those same 2 numbers, they are going to either add or subtract to the coefficient of the middle term. Okay, so I'm looking at this example. And I have it typed out right here. What are the factors of 15 that when I add them, I get 8? What numbers divide 15 or multiply to 15? I mean, they'll divide 15 as well. And that when I add them, I get 8. Well, 15 is either equal to 1 times 15 or 3 times 5. Those are the only pairs. Well, it's got to be the 3 and the 5, because when I add 3 and 5, I get 8. So my answer in factored form here is, I set up my 2 binomials. I put an x here and an x here. This, I know a lot about factoring, and so I'm going to say this means the signs are the same. They're both positive, so it's plus plus. And I know it was 3 and 5. Now I'm going to check it. X multiplied with x is x squared. When I multiply the outers and the inners, I get 5x, and 3x is 8x. And then 3 times 5 is 15. It works. If there are no combinations that exist, the polynomial is prime. I will tell you that on this factoring packet that I mentioned before, there are no primes. Okay? It says, you know, factor or tell that it's prime. But there are no primes, so please don't put prime on there. They all can be factored. Factor the trinomials. All right, you got to keep in mind the signs. Now, here's something before we do these problems that I want you to copy. So I do want you to pause the video. If we were a live lesson in class, I would have this up on the screen, and the students would be copying it. Okay? And you might want to use colors because it's a nice visual, the colors. So pause the screen and copy this. I'm going to zoom out a little bit more so we can see everything on the screen. Okay, I've got 4 things. All right, that should be good. I'm looking at it on my screen. Okay, I paused a little bit there because I was giving you time to pause your computer, and hopefully you have copied this on a video pause. I'm going to explain it now. This is a quadratic expression, ax squared plus bx plus c. It's a polynomial. We don't know what a, b, and c are, nor do we care right at this particular point. But I want to talk about the signs, because I believe that this is the best way to learn about factoring. You know, if you see, I can have four possibilities. It's plus c and plus c on the end, or minus c and minus c on the end. And then over here, it's plus bx plus c, or minus bx plus c, or plus bx minus c, or minus bx minus c. Okay, those are the only four combinations that I could have for polynomials and their signs. So I always read this backwards. What two numbers multiply to give me this? That when I add them, give me this number. The signs are the same when this is plus. They are both positive. Okay, this one, backwards. What two numbers multiply to give me this? That when I add them, give me this b value. And the signs are the same, the signs in the polynomials, okay? They are both the same in these binomials. They're both negative. So this would be a plus plus, right? Signs are the same. They're both plus. This would be x plus, x plus. This would be both minus minus. So it would be this, x minus something times x minus something. Now here, when it's minus, this means you're subtracting these factors to get your b. And this also means the signs are different. So one's going to be plus and one's going to be minus. There's no rhyme or reason where you put the plus or minus, except that whatever this is, okay, your larger product has to be plus. And I'll talk about that more when I'm actually doing some of these factoring problems with you. So again, this means signs are different, and I'm going to subtract. And this is the sign of the larger product, meaning the product of the outers and the inners. Okay? Outers and inners, the product. Multiplication. Again, I read this backwards. What two numbers multiply to this that when I subtract them give me this? The signs are different. The sign of the bigger product is subtraction. Okay, so hopefully you have this copied down. You're keeping it as part of your notes. I would do it in color or highlight this stuff. And let's now take this and apply it to the examples that are on our notes sheet. Factor the trinomials. Okay, I've got a 5. So I want to know, what two numbers give me 5 that when I subtract them, it's going to give me a 4. Well, 5 is prime, isn't it? So there is only one combination. It's 5 times 1. So I'm going to set up my two binomials. I know it's x, I know it's x, I know it's 1, I know it's 5. The signs are different. Subtract, different signs. This is the sign of the larger product. So you have to ask yourself, what's the larger product of my outers and my inners? Okay, larger product, I'm talking about the product of the outers and the inners. Is 5x bigger than 1x, or is 1x bigger than 5x? And you say 5x is bigger, so 5x gets the negative. The negative has to go here in order for me to get a negative 5x. The positive goes here. And if you check it, you're going to end up with your original, because remember, you're dividing this. So since we're dividing this by factoring, when I multiply this out, I should get the original problem. Okay, here, I read it backwards. I'm like, oh, I'm looking for factors of 45 that when I add them, give me a 14. So I know I'm going to add. I also know in my binomials that the signs are the same. And this tells me that they're both subtraction. This is just a 1x squared, so I got x here, x here. I know they're both minus, minus, minus. What two numbers multiply to give me 45 that when I add them give me a 14? Well, that would be 5 and 9. Okay, because 9 times 5 is 45, and 9 plus 5 is 14. So I'm done. Hopefully you enjoy factoring and find it fun, especially when they are a little bit more challenging. When they're easy, they're kind of boring. Okay, this. Am I going to add or subtract? And you say subtract. So I'm looking for numbers that multiply to 50, then I'm going to subtract them to make it equal 5. Are the signs the same or different? Meaning the signs in your binomials, are they the same or different? Well, mine says they're different. All right. This, since I've got different signs, this is the sign of my larger product. Remember, it's the product of the outers and the inners that I'm comparing. All right, x squared. The only way to get x squared is x times x. We know the signs are different. I'm not going to put the signs in yet. When they're the same, I fill them in right away. But when they're different, I don't. I have to first figure out what two numbers multiply to 50 that when I subtract them give me a 5. Well, that would be 5 and 10. Now, I need the larger product to have a sign of plus. What's bigger, 10x or 5x? You say, well, 10x is, so I have to put a plus on 10 and a minus here. And when you check it by doing a FOIL, you will get that original problem. So trinomials, when the a or the leading coefficient is 1, not so bad. Onward to the next type. Notice that the examples that we just factored all had 1 as the leading coefficient. What happens when the leading coefficient of the trinomial is more than 1? You're still going to use trial and error. Factor. This, look, this is more than 1. Now you have more trial and error to do. These are trickier. The leading coefficient is 2. Now I need to also consider factors of the first term. And then you have to strategically place the factors of the first and the last terms and then test the combinations. There we go. So what I like to do is I like to list the factors of the leading coefficient on the left side, and I like to list the factors of the constant on the right side. I know that I'm going to subtract, and I know my signs are different. Okay, so that's my little thing that I'm thinking about. This means that's a sign of the larger product of the inners and the outers. All right, so my factors of 2 are 2 and 1. My factors of 3 are 3 and 1. I like to list them really tiny on the sides. I'm going to set up for my binomials. Now, I have to play the game. You know, this is kind of like is this 2x and 1? Is this 3x and 1? Or is it 1x and 2? Okay. Well, these are for my x's. So it's either 2x and 1x is the only combination that I can use. So I can do that in there right away. But I have to get a 5 in the middle after I subtract. So am I going to multiply the 2 with the 1 and the 1 with the 3? Well, if I do that, that equals 2 times 1 is 2. 1 times 3 is 3. 3 subtract 2 is 1. That's not 5. So I have to switch it. 2 multiplied with 3 is 6. And then 1 times 1 is 1. And when I take 6 and 1 and subtract them, I do get 5. So the 3 has to go here to multiply to get my 6. And my 1 goes here. This is the sign of the larger product. What's bigger, 6x or 1x? 6x, so that gets plus, and that gets minus. Not too terribly difficult if you know what you're doing, and you can set it up. 6x squared, subtract 17x plus 12. Well, my job is always to look for a GCF, but this is even, that's odd, that's even. Even and odd don't have common factors other than 1, so forget about it. And these are small numbers, so it's whatever. I just got to do this trial and error. So I've got a 1 times 6 and a 2 times 3. Those are the only ways I can get 6. A 12 is a 1 times 12, or a 2 times 6, or a 3 times 4. And I believe I'm out of other factors for 12 because 5 doesn't divide it, 6 does, but I already have it listed here. I know I'm going to add products to get 17. And I know my signs are the same. So, since my signs are the same, you could fill the signs in. I usually do it last, but you could. But I don't know if this is going to be a 6x and a 1x, or if this is going to be 2x and a 3x. So I have to wait till I play around with my factors. Usually if this number is pretty close to these numbers, usually it's the factors that are closer together on the number line. You know, so if I consider a number line and I've got a 1 here, a 2 here, a 3 here, a 4 here, a 5 here, and a 6 here. Do you agree 2 and 3 are closer together on the number line than what 1 and 6 are? So I'm thinking it's 2 and 3, and I'm also thinking it's 3 and 4. Now, I usually do this with pencil so I can erase in case I'm not correct. So I have to multiply to get a 17. All right, well, 2 times 3. 2 times 3 is 6. 3 times 4 is 12. When I add 6 and 12, I get 18. That's not going to work. How about 2 multiplied with 4? That's 8. 3 times 3 is 9. Oh, 8 and 9 is 17. So I like to underline this. The 2 has to get multiplied with the 4 to get me my 8. And then there's my 9, and when I add it, I get 17. Ooh, yay me. So I know I'm using the 2x and the 3x. I know I'm using the 3 and the 4. The 4 has to get multiplied with the 2, so it goes here. And the 3 goes here. Because this is my 8x, and that's my 9x, and 8x and 9x is 17x. The signs are the same, they're both minus. So again, hopefully you did learn this way of factoring by writing the factors and playing the little trial and error game, and the thing about the signs. Okay, remember, when the signs are the same, they're both whatever's in the middle. And one more. Why don't you pause the video and see if you can come up with the correct factorization of 8x squared plus 33x plus 4. 33 is prime. It has no common factors with 8 and 4. Okay, hopefully you paused the video and we're back. 1 times 8 and 2 times 4 gives me 8. 4, well, this one's easy. It's either 1 times 4 or 2 times 2. Now, this number right here, 33, is much bigger than 8 and 4, so it's probably factors that are farther apart on the number line. You know, like 1 and 8 are farther apart than what 2 and 4 are. 1 and 4 are farther apart than what, well, 2 is itself. So it's really close, like right on top. So I'm thinking because this number is much bigger, that it's these factors. I'm going to test it because it's trial and error. You know, if you fail, then you got to try again. All right, I know that my signs are going to be the same signs, and I'm going to add my products. Add, and here's same signs. This means they're both plus. All right. Well, remember, my magic number is 33. I can see it right now. 8 times 4 is 32. 1 times 1 is 1. 32 plus 1 is 33. So I know without a shadow of a doubt it's 8x and 1x. The 8 had to be multiplied with the 4 to make it big, to make it be that 33. And the 1 goes here. Signs are the same, they're both plus. That here ends our lesson for the day. Yes, the video is almost 34 minutes long, but you would be in a 34-minute lecture in class. Anyway, the homework assignment is 1 to 29 odd on page 57. If you have any questions, send me a message, post a comment on the discussion. Make sure that you print out this packet so that you have it. It's going to be due, the date's on the calendar. Have a great night.